Okay. So yesterday we just started seeing about a lot of information about CNN. At the time that we have seen some of the playgrounds of TensorFlow and also the graph cloud and other informations. We have discussed the problem statement, how it is important and everything. And CNN, I think we touched upon all the things and we downloaded the datasets and how it has been read. Right? Okay, so after giving this input, and it is going through the ReLU process that is called as activation function. Without activation function, it is not read. Otherwise, without ReLU, it is taking the entire image for the processing. So by applying the activation function, it is taking only the relevant information from the image, and then it is getting into the pooling structure. So what is pooling, right? That is very important. The pooling layer section would reduce the number of parameters when the images are too large. Spatial pooling, also called subsampling or downsampling, which reduces the dimensionality of each map but retains important information. This is what has been the important structure of CNN. While reading the image, if it is too large, it is not going to read all the information which is represented by the image, and instead it is just reading, or otherwise it reduces the dimensionality, right? And then it is it retains the required or important information only. Okay. So in this pooling layer, we have three different types of spatial pooling, what is called as maximum pooling, average pooling, and sum pooling. Okay. So before this pooling, okay, this is pooling, and before this, we have to see one more process called strides. So yesterday we just touched upon this image, how it is getting convoluted, right? So the convolution is the first layer to extract features from an input image. Convolution preserves relationship between pixels by learning image features using small squares of input data. So it is a mathematical operation that takes two inputs such as image matrix and a filter or a kernel. So even in machine learning too, we have used kernel operations, yeah, the kernel functionalities. Here in deep learning also, it is we are taking care because it is one of the operations. It is going to take it into consideration while doing the process. So this is for a kind of what all the information to be filtered out, so that that process will get smooth. So that is called as the kernel processing. Okay. So this is the 5 by 5 whose image pixel values are 0, 1, and filter matrix 3 by 3 as shown in below. So this is the 5 by 5 image matrix, and this is after filtering, we are getting this image. This is the original image. Just assume that you are giving your own image. In that image, it is just trying to reduce its own image so that it will just read only the required information. That is called as convoluted image. So it is the original image and it has its own value 0 and 1. And after filtering it out, right, after applying the important information which has been read through the images, it is called as filter image, right? That is called as convoluted image. Okay. So then the convolution of 5 by 5 image matrix multiplies with 3 by 3 filter matrix, which is called feature map as output shown below. Okay. So after this, it is just going to 3 by 3 layer with the original image so that it is calculating all the values within the matrix. You know how the matrix calculation or matrix addition will be happened. Same kind of matrix addition is happening over here. You just see the animated image, and this is how it has been calculated in each and every array cell. This is one cell, second, third, fourth, fifth, sixth, seventh, eighth, and ninth. So if you have a 5 by 5 matrix, and you'll get the convolved feature after the applying this technique, the addition of matrix. So convolution of an image with different filters can perform operations such as edge detection. See, these are all the things happening over here in this process. Edge detection, blur, and sharpen by applying filters. So the below example shows various convolution image after applying different types of filters. So these are all the operations, different operations. With respect to this operation, the filter array or matrix, it is shown. And after you applied this filter, this is the right side, whatever you see, this tabular column, this is the convolved image. Okay. So this is the entire identity of the original image after filtering the normal filter. So this doesn't have too many things. And then the edge detection, during the edge detection, the four sides, not only the four sides, all the edges. Yeah. And it is just, this is the, this, zoom in. Okay, so this is the edge detection, and this is another edge, and this is a very much clarity image of edge. And after this edge detection, it is just storing its own value in its image in the process, and then it is getting sharpened. Okay. And then it is normalized. So this is where during the normalization process, only, it is trying to identify this image is represented. I mean, this is a representation of this image, whether it is a dog or cat or whatever, human being, whatever it is. And then it is applying the uh, optimization technique like Gaussian or standard gradient descent functionalities optimization technique would apply, and then is trying to detect what is the image is all about. So this is all about the filters. Okay, so first you are giving input as per this. Yeah, first you are giving this input, and then it is getting convoluted, right? And during the convolution process, we are having so many filters, right? In that, so many filters, we are trying to identify the edge detection, the other parts of important image detection, and then the convolved images and other things happening. And we are applying some optimization technique as well, right? The image is getting sharpened. And after this, one of the important technique is happening. What is that? It is called as stride. So stride is the number of pixels shifts over the input matrix. Okay. Stride is nothing but it is the number of pixels shifts over the input matrix. When the stride is 1, then we move the filters to 1 pixel at a time. When the stride is 2, then we move the filters to 2 pixels at a time, and so on. So the below figure shows the convolution would work with the stride of 2. Okay. So if you just take this as an example, only this colored image, matrix, and if you just calculate, and it will just it is keep on adding, but it is a straight of 2. Okay, so convolve with 3 by 3 image filters filled with ones, and so it is a 77. It's an order. Okay, so it is giving an order, and if you are taking the 5 by 5 matrix, 5, 5, 5. Okay, the 5 by 5 matrix, and how it is getting convolved with the how it is getting shifted the pixels, and that is the calculation. Each and every box has been calculated with the number of numbers, and this is the side of 2, right? And okay, see here how we will decide the strides. So we have to how we decide the number of strides in CML. operation. The stride is the number of pixels, the filter moves at each step along the input. The common stride values, stride equal to 1, it starts with. The filter moves one pixel at a time, which retains more spatial detail but increases computational cost. So that is why, we are giving as much higher number as possible in stride because it occupies more memory, right? And then stride greater than 1, the filter moves multiple pixels at a time, reducing the size of the output, feature map, and computational cost. Input size is, for example, 6 by 6, filter size, and then 3 by 3, and stride would be resistive calculation. And this is how it will move one pixel to another pixel, like how this has been shifted, how this has been shifted. Yeah. So actually, this is one spatial value, I mean, a stride value equal to 1. If we just increase stride value equal to 2, then the calculation would be like this. Okay. This initial time, at the beginning of the image detection, maybe you have to understand this, and then slowly, if you just progress on RNN and other GenAI models and other models, then you will be able to accustomed to this stride values. Okay. What are the factors affecting the charge of stride? It is based on the application specific goals. So high spatial resolution, use smaller strides, stride equal to 1. Retains more spatial details of the input, useful in tasks like image segmentation or object detection. So if you are using high spatial resolution image, then stride, obviously you have to go with the stride equal to 1. Faster computation and reduced feature map, then you have to, you can go greater than 1 to any extent, because feature map application will be taken care at the back end of stride, so that you don't have to worry. So this reduces computational load, memory requirements often used in classification tasks, because CNN mostly and widely used for classification purposes, right? Because if you are having industry, if you are having software company, if you are just installing, image detection or facial detection, you don't have to, do the fingerprints or any other thing. You just cross the device. That's it. It will take care of your, the basic details of your, um, um, what is that, eye, right? And then even your body shape and your body structure, based on that system, it will easily identify. But still, we need to set the primary key factors or primary value in those image setting processes, so that every employee will just we stand for what is 1 second or 2 seconds, and then it will just identify that's it, right? So these are the process. Okay. Input size. Large inputs can tolerate. So these are all the things that we are trying to study. Okay. I wanted to give you this, I mean, the information about stride, how it is getting calculated. If we just slowly getting into the process and try to understand how this has been calculated, and take your time and do, and I mean, whenever you find that calculation, it will be really amazing to see. But we are not going to do anything, but we need to set the slide. That's it. Rest of the thing, it is giving you the freedom. The library is giving you, especially conceptual. Okay, now it is padding. So convoluted, and then the array, the image filters, and then the strides, and then the padding. Sometimes filter does not perfectly fit the input image, and we have two options in that case. Pad the picture with zeros, that is called zero padding, so that it fits. So drop the part of the image where the filter did not fit. This is called valid padding, which keeps only valid part of the image. It's very simple, and you no need to do further explanation for this. Padding, it is kind of a benchmark. Okay. Unwanted information it drops, unwanted resolution it drops, right? If you want that particular piece of information, maybe if you are finding it, this is a 32 cell I want because I want it at the back end, uh, that image or the cell or pixel I want it, then and it doesn't have any value, then you have to fill with the zero. Okay, so that is how the zero padding works. And you have to give the option padding. That's it. Padding what? You put zero or whatever the padding options, you will see during the coding process. I mean, that kind of a technique you should learn from this knowledge, and then only it becomes as a skill in doing the CMM process. Okay. Relu, we have seen the yesterday, what is just an introduction about Relu, right? It stands for rectified linear unit. And also it is one of the activation function, and it is very critically used in many processes. Okay, just 1 second. Okay, why ReLU is important? So rectified linear unit, right? Actually, the name is rectified linear unit, but this is used for non-linear operation because from converting non-linear operations into linear. That means we are trying to classify images with respect to this ReLU function. Maybe you'll be able to visualize like this. You have unsupervised learning model, and you are trying to do a lot of classifications, right? In those things, we are applying basic machine learning, algorithm and other stuff. But what is happening most of the time, during the process of uh, processing the unsupervised data model, first of all, we need to classify it, group it, right? What kind of a data it is, and in what way we can classify our group so that we can identify the exact whatever the problem statement or problem occurring, then you will be able to solve through this algorithm. Say for instance, take it Uber, and you are standing somewhere and you are ordering, you are trying to book a car, and it is literally unsupervised learning model, and you just placed over there, and it is just going and finding out the respective driver, and that is the peak time. Okay, and how it should be classified? First it is search from the existing classified group. That means the first 1 kilometer, second kilometer, I mean, yeah, third and fourth and fifth kilometer and so on, and it will stop somewhere. That has its own benchmarking system. To certain kilometer it won't find, and it is what will happen at last, again It will stop somewhere and it is giving you that, will not be able to find out the right partner for you, and then it will just, close the session. And then again, you are just retrying for the second time, maybe, for the second time, somewhere beyond the control, maybe 60 kilometer or 70 kilometer, you will be getting a driver, right? But that will cost you more. And that is how the peak time or peak hours will work, right? In a similar manner, from in this, so I mean, in this process, from non-linear information, we are trying to cope up with something. We are trying to group, or we are trying to classify the information. But actually, it is a non-linear. It is not linear. It is going beyond your control until the algorithm controls you. I mean, control the classification or grouping of the data. Then you will find the linear data, right? It's straightforward information. If it is beyond your control, and if you choose the 70 kilometer cab driver, then you can't afford, and the cost would become, double the expense, right? And why we need to go for the, again, you have to wait for some more time. That waiting period only, they are making their utilization sometimes, most of the time. Peak hours in Bangalore and Chennai all the time, kind of every peak hours, right? There is no more, specification of, because 24/7 people are working, morning shift, evening shift, night shift, and it's just rotating. So everything, even in the night time, if you are just, untimed, right? If you are booking, it's almost 2x or 3x the rate. So in almost all the public transport also, they are charging 2x. Likewise, the private institution also, their organization also, they are charging. So almost it is a non-linearity just exists, but we are converting somehow into linear position. The same way, if you are just giving one image as, it is like, the non-linear image, because the image is not clear, the pixel is not clear, and somehow, you are, trying to train this image, and from this image you are trying to get some output. In those cases, most of the time, okay, most of the time, you are, doing the non-linearity into linearity. In that case, we are applying this activation function called the ReLU. Yesterday we have seen TANH. That is also one of the activation function. One more thing called, that is also, TANH, right? TANH, sigmoid, linear, and ReLU. So by comparing with these three, ReLU is the most optimal, option, so that it is giving you the optimized result. Okay, that is why we are going for ReLU, and ReLU, this is what it is. The real data would want our convolution and net to learn would be non-negative linear values. That means it just safeguard you by going through the down. It is not going, and it is not trying to find out any kind of a negative value. And even though the model is trying to get the negative values, it's converting and trying to convert into the positive values. Just to see, there are some negative values. In that negative values, it is trying to fill out the zeros. Because if you just take the average of this value, then you just maintain the positive stream of information. Okay. So there are other nonlinear functions such as tanh or sigmoid that can also be used instead of ReLU. Most of the data scientists use ReLU since performance-wise ReLU is better than the error. This is what we have discussed. Okay. Look, next is pooling layer. We already just seen what is a pooling layer. In that pooling layer, maximum pooling, average pooling, sum pooling. The maximum pooling takes the largest element from the rectified feature map. Feature map is nothing but the feature scaling. So don't worry. If you just consider an image, if you are just, doing the feature map, that means it is taking the important characteristics to map your request. That is called feature map. Okay, don't worry about the terminology. So feature map is nothing but it is trying to find out its original, I mean, the maximum characteristics. What are the characteristics it will be able to read, and it will be taken care of. Okay, and it is trying to map it towards the characteristics. So taking the largest element will also take the average pooling. Sum of all elements in the feature map called as sum pool. Okay. So this is a single depth slice. It's a one, the matrix, the maximum pool which do the two filters and stride equal to two. And in CNN operation without stride, nothing is wrong. If you are giving the default value, it is taking only stride equal to one value. If you wanted to increase the computational processes or performance or otherwise, you have to give greater than one value. Just you have to take care of this. This is the maximum pooling you are getting from a 2 by 2 filters. Okay. So if we just apply this information to this, and we will be getting the value and how it is getting calculated, and through this kind of animated information, right? And how it is jumping from one matrix into other matrix, and this is how the calculation of, okay. And this is exact matrix addition we are using. Even this here same kind of a matrix addition. Okay. And here the same kind of a matrix. Okay. Just get to know this. That's okay. How it is getting calculated, how from the maximum pool, how in-depth information about the image it is reading. That's it. Rest. The last one is fully connected. The layer we call as FC layer, that is fully connected layer. We flattened our matrix into vector, right? So we already, discussed about the SVM model. In the SVM model, what is vector and how the vectorization is happening, and everything, we have done. And feed it into a fully connected layer like a neural net. Okay. So just to see, this is the input x1, x2, x3, x4, right? And how it is getting flattened and how it is getting relations with this, all the informations. Okay, right? And in the above diagram, the feature map matrix will be converted as vector, like x1, x2, x3, x4. With the fully connected layers, we combined these features together to create a model. Yes, right? So finally, we have an activation function such as softmax. So, so softmax is also a mathematical function often used in the final layer of CNN. So, especially in classification classes. It converts the raw scores output by the network into probabilities, which sum to one, right? The purpose of softmax function maps the vector of real value scores, right, into a probability distribution. It ensures that the output probabilities are in the range 0 or 1, sum to 1, making them interpretable as probabilities for each class. Yeah, CNN trained to classify images into n classes outputs, logics like 2.5, 1.0, 2.2. Likewise, these are all the things. The softmax function transforms these logics into probabilities. Okay, so probability always, the value between 0 and 1. So it is trying to convert this, model into 0.7, 0.2 to 0.08, where the sum is 1. It is what is happening in the softmax. It is again optimizing the image with respect to the um, how to identify and how to predict this, how the prediction is going to be in the future. So for instance, you already got trained for a dog. Maybe we have 4,000 images of a dog, and you are just giving the training images, and you are giving one more image to test whether the training model, this model is working fine. So you are giving cat image to test it. Okay. And what it has to say, uh, either, I mean, you have to set a message anyway. That is a different option. But it has to identify that it is not a cat. I mean, it is not a dog because we are just inserting a cat image. So obviously, this model has to identify this is not a dog. This message has to come for the user. So at that point in time, what the final layer, okay, if you just look at this image, a convolution is happening, feature maps and characteristics has been read. Again, it is going into feature maps with pooling, padding, ReLU, all the things that is happening. It is getting fine tuned during the training process. From this image, from the one image, it is trying to read and getting in, saving all the information into one place, right? From the fully connected layers, after the fully connected layers, because it is all the informations. Maybe one unit will have one information, second unit will have other information of this image, and the third unit, third layer, this having other the characteristics. That is called the feature types. Okay, so all the things it is getting connected. I mean, that is why it all it is getting fully connected, and it is just piling up. And now you are testing it because you already the images, for instance, 4,000 images of the dog has got trained like this. Just imagine this is a cat. Okay, so we are applying the convolutional model value, and we are, from the starting phase itself, we started the activation function. Then only it will get activated. Without ReLU, the image will be very, very vague. It will never be able to identify. And then it will just read all the characteristics. We are applying the pooling condition, we are applying the padding conditions, we are applying all the things in each and every phase. And the convolved image and the ReLU is also just continuing, and it is taking care and across, after all these feature characteristics and after all these things, for a single image, it has all, it is just spread out like layers like this. Okay, just imagine, this is all the information. I mean, each image kind of, it's reading pixel by pixel because it's an array, and it is just imagine if you are just giving your passport size photograph. One layer may be the top edge, the top corner of your image. And the second layer may be the next the layer, the array of information, and R matrix, I would say. The matrix of information is getting stored like this. At last, you are giving your own, maybe other images. Okay, maybe Senthil is giving testing whether this model is able to identify the Senthil's image or not. At that point in time, the Softmax has been applied. This Softmax will be able to predict if it is goes beyond the one. It is trying to control and it is trying to minimize its accuracy or minimize the error so that it will increase the accuracy, right? So that it will give you the right prediction during the Softmax. So Softmax is the decision point because the first one is activation function, you are applying value. At the end of the function of CNN, the softmax is getting applied. Then that model will be able to identify the image. So the exponential transformation, how softmaxes work. Logits are exponentiated to make them positive and amplify differences between scores. So higher logits, so we already seen all the negative is getting into positive, and higher logits result in larger exponential values, making the corresponding probability larger. Normalization, exponentials are divided by the sum to scale the values of the probability distribution. So exactly what is happening, sometimes after applying all the ReLU and pooling, padding, sometimes the image will have will be in a confused state. Say, for instance, maybe this image it is getting identified because of the training, and we are giving so many images we are training. Okay, but during the prediction process, because ultimately, why we are using CNN model? What I mean, see this scenario in your office, they are implementing the facial recognition software, facial detection software, and before that, it has to capture all your videos and images, right? Then only, first it has to read all the employees' details, personal details of images and how they look like in a lot of postures, even in the banking software. Okay, like Jupyter or all the online, account open system is there, right? Zero balance account, like Kotak, Mahindra, and other the brands. They are, taking from a lot of angles. Okay, until then, you finish the information, the basic personal details. It won't, it won't open an account. The similar way, you are giving training, but while you are just coming to your office, it has to identify this is somebody. And how it has to identify, that should be the primary and the most important feature maps. It's already been captured. And whatever the shirt, whatever your look, maybe at the time of giving your information, where you don't have mustache. Maybe, after some days, you have mustache. Then how it is getting identified. It reads the basic characteristics, and that is the key. And based that basic characteristics to store the information, the softmax is needed. That's it. Very simple, the layman terms. This is how the final layer, will be working. So in multi-class classification problems, the output of the CNN is typically a vector of logics with one value per class. The softmax function is applied to this vector to compute the class probabilities. The class with the highest probability is the predicted model. Okay. Without softmax, the prediction still will be a confused state, so that your accuracy will be less. Okay. So here also, we will be training with cross entropy loss so that it will reduce the error. So softmax is often paired with cross entropy loss function during training. So the cross entropy loss evaluates the difference between the predicted probability distribution and the true value, that is one half encoder. We already seen about what is one hot encoder and how it is getting transformed. So this combination ensures efficient and stable training. So why we are using softmax? Probability distribution, interpretability, mathematical stability. Okay. So for every library or every function we are using, it has its own limitations. So sensitivity to large logics. If logics have very large or very small values, both very large